Hello everyone, welcome to another session. Today we are going to look at the four linear motion equation and we are going to derive it. Let's start with the first one, the first linear motion equation. There we go, first one. Now we will look at the formula acceleration is equals to final velocity minus initial velocity over time. However, we want to change all of these variables into something much more simple. So we change acceleration, the ACC there, into A. Just change it. We're just changing the variable. We're not doing anything else. And the final velocity, we're going to change it into V. Initial velocity minus here, we're going to change it into U. And the time we're going to just put time because it's a very easy variable. Next, we want to bring the time over to A, so we will get AT equals to V minus U. And next we want to bring the minus here, the minus U, to this side. So we will get U plus AT equals to V. Now we're just going to rearrange this into, we're not doing anything, we're just going to rearrange it. V is equals to U plus AT. There we go, beautiful. Now as you can see here, this is our first linear motion equation, and it's basically the same as this. We just rearrange it back to make it look nicer, and this is going to be our first linear motion equation. Now let's look at our second linear motion equation, shall we? I'll just draw a line here. Now our second linear motion equation goes something like this. Displacement, I'll just put displacement is equals to average velocity plus times time. As you know, using the formula, d is equals to v times t, so that's where we get this equation from. Now the average velocity is the final velocity plus the initial velocity over 2. That's how we get the average. So how we get average in a situation. You just put it back times t there, beautiful, like that. Now we can make this thing look actually a bit nicer. We're going to change displacement. We're going to change it into s, and this is still displacement, mind you. This is still displacement. We're just changing the variable. And then we're gonna bring the half outside, so half is gonna be outside. It's gonna be a bracket here, nice, like that. And we're gonna change the VF into, as we changed earlier, into V, and we're gonna change VI into U. There we go, nice, like that. And then it's times t, so t is gonna be here. Now mind you, the half is still here. It's just we bring it outside. We factorize it out of this equation. We bring it outside. That's why we have half here. And let's change the place of v and u. Let's just make it u plus v instead of v plus u, so that it follows the textbook I'm using. So there we get our second linear motion equation. Beautiful, right? The second linear motion equation. Now let's go for the third linear motion equation. Let me just draw a line here, nice beautiful line there, so that we don't get mixed up. Now that's our third one. So for the third one, we're gonna use our first equation. We're gonna substitute it into our second equation. So what was the first equation? The first equation is this one. So v is equals to u plus at, and our second equation is s is equals to half u plus vt. Now we're going to substitute this v into this one right here, this v. So we're going to put it there. Now we get s is equals to half u plus at Beautiful, right there. All right, after we get that, there we go, we can have u plus u, so we get half 2u at, sorry, plus at, there we go, plus at, t is still on the outside. Now we're just going to open this bracket and we'll get u, and once we open this bracket, this will be times n. Don't forget we also have a t here, it will also be times n. So this one first, half times 2 will get u, and then the t will be times n, so you get ut, plus half will be times here, so we get half, this is actually a, just draw it properly, I don't want you to get mixed up, half a, then the t is going to be times n, you get t squared, and this is still s. So this will be our third linear motion equation. Ta-da! We already have our third. Now let's see our fourth linear motion equation. I'm just going to draw it right here down there. I'm going to draw it right here. Alright, beautiful, so that we don't get mixed up. I'm just going to put some barriers. Alright, so our fourth one, what we want first is we get our first equation, we're going to square it. So our first equation is v is equals to u plus at, there we go, that's our first equation, as you all may remember. It's this one, first equation. Alright, now we want to square it, we want to square the first equation, so we get v square is equals to u plus at bracket square. Now mind you, when we square the equation, if it only have one variable, if it only have one I would say individual at one side, we can just square it like this. But when we have two variable, we can't just use u square plus a square t square. It doesn't work like that. This doesn't work. It's not. So when we have two variable, all we have to do, we have to do a bracket, then we have to square it like so. We have to square it with a bracket, and that is the rule if you want to square an equation. But if we have only one variable, like so, only v here, we can just square it individually like this. So I hope you guys don't make that mistake whenever you do your maths. So we get v square, and then this u we can make it like so, at. Instead of putting square, we have, because it's u square here, we can put another u plus at. Alright, and then we can open the bracket. This times by this, you get u square. This times by this, you get u at. So then this time by this, you get another u at, so you get 2 u at or 2 atu, doesn't matter. And then this times by this, you get a square t square, a square t square plus a square t square, obviously, and the v square is still here. Beautiful, like that. Now we are going to substitute. You still have u square here, but for these two, we are going to substitute 2a out of the equation. So we're gonna, this is an a, let's draw it properly. So we're gonna substitute 2a out, so you get, sorry, not substitute, we're gonna factorize 2a out. So we're gonna factorize it out, put a bracket. When you factorize 2a, you get 2ut. Oh, sorry, you already factorized 2 out, right? So you're just gonna get ut plus half at square. Beautiful, like that. And we can see that when we factorize 2a out, this equation, this nice equation in the bracket, is actually from our third equation. I'll show you here. There we go, third equation, ut plus half at square. Ta-da, ut plus half at square. So yeah, you can just put that as our third equation. So the third equation, ut plus at square is equals to s. So you can put s down there. So u square plus 2a s, there we go. Beautiful. So you get here still v square, and this is going to be our fourth equation right there, fourth equation. There you go, beautiful. So there you have it. All of the 4 equations have already been derived. You don't have to derive it, but it's really good to know and to understand where this equation comes from. And in later on in the video, in other videos, we're going to discuss on how to use this for equation. And just stick around, maybe you learn something. Thank you very much. Have a good day and see you soon.